Okay, right into the equations here. Deriving equations. There's 3 of them. They range from relatively easy to fairly challenging. So stick with me here. We'll do a little warm-up one. I like to call the first equation equation 1.
Great name.
Are you familiar with A equals delta V over delta T?
Sure.
You should be, right? Acceleration is delta V over delta T. Now, we can rewrite that. What does delta V really represent? Yes, that's true. That's one root. Delta V means change in velocity, right? And the change in velocity is the difference between the final and the initial. So I'm going to rewrite that as Vf minus Vi, right? Delta V is Vf minus Vi. And similarly, delta T is going to be Tf minus Ti. Now, 99.9% of the time, the initial time is equal to 0, right? Because timing starts at 0. Right? So generally, the Ti just is going to be minus 0, and it kind of just very much disappears. Kind of, sort of. Okay? So I'm just going to rewrite this as A equals Vf minus Vi. And I'm just going to call Tf, I'm just going to call it T. Time elapsed, right? Some books like to leave it as delta T. Some books like to leave it as delta T. I'm going to try and simplify it so that there's less sort of confusion. Okay, now I'm going to rearrange this. How do I get rid of divide by T? Multiply both sides by T, right? Multiply both sides by T. This side cancels. Over here I get AT is equal to Vf minus Vi. And I'm going to solve for final velocity. I'm going to write it as minus Vi, I'm going to take to the other side. I get Vi plus AT is equal to Vf. And traditionally, we write it as Vf equals Vi plus AT. And I'm going to put a box around that. That is special equation number 1. Special equation number 1. Did I tell the truth? Was it a fairly easy derivation? Not too bad. The final velocity is the initial velocity plus whatever you get by accelerating over a period of time. Are we good? You will now be expected to use that formula, Vf equals Vi plus AT. I've said it so many times, I probably can recite it in my sleep. All good? Okay. Equation number 2 is a considerable step up. I like to call the second one equation number 2. Well, you know. And I'm going to also remind you that displacement is the area under the VT graph. Displacement is the area under the VT graph. Let me see how my handwriting did there. Oh, pretty close. Displacement is the area under the VT graph. Okay, so give me a second here while I draw this, because I always mess it up a little bit. Okay, so I've got a VT graph. what is the type of motion that's happening here as the velocity, the red line here? What's happening to this object?
Acceleration.
It's speeding up, it's accelerating, right? Excellent. Okay. So if I want to know the displacement, it's the area under the dt graph. It's this area under here. Right? It's that guy in there, right? Now, what shape is that guy? It's a rectangle on the bottom, triangle on the top, right? If I did this, does that help you identify what shape it is? Very well done, trapezoid. Trapezoids traditionally look like this, right? I always think of them as being underneath elephants at the circus. Okay? Is this the same shape as that? No? Okay, well, does the trapezoid have to have, could it be like this? What is the definition of a trapezoid? It's a shape, quadrilateral, where only one set of sides is parallel. I heard someone back there say it. A rectangle is when two sides are parallel, right? Those guys are parallel to those guys. Trapezoid is there's only one. Well, here, they don't have to be like this. It could be like that. It could also be like that. Or one could be straight up and down. There's no rule about it being straight up and down. It could be straight up and down on one side, sort of at an angle. I've kind of got off at a bit of a tangent here. But the point is, does anyone know? I'm going to ask Ryan, because he's the trapezoid expert apparently. Do you know what the area of a trapezoid is, the formula, Ryan? I have to think about it, so. Area of a trapezoid. It's okay to say no, I don't know. Don't know? Anyone? We could ask the Google machine. I do know it, because it's right here in my notes. Anyone know the area of a trapezoid? No? Okay.
I don't know.
Yeah, it's side 1 plus side 2 divided by 2 multiplied by the height. Side 1 plus side 2 times the height. Okay? So, in my trapezoid, this one here is side 1, this one here is side 2, and my height is that guy there. Okay? Parallel sides are the sides, and the height is the other one. Okay? Now, where does that fit over here? Remember, I rotated that thing, right? Yeah?
I don't know what's happening.
What do you mean my shading's off?
It's really messy. Like, what's up with the
Well, the whole thing is shaded. The whole thing, like I could do this, I guess. No, I can't. The whole thing is shaded in. Okay? I don't have to shade it too, I guess. Side 1 plus side 2 divided by 2 times the height. Times the height. Okay? Times the height. Okay, so I'm going to rotate this guy back. That means that side 1 is down here and side 2 is there, right? And the height is there. So what are my side 1 and my side 2s on my little graphy thing? Well, side 1 is there, and side 2 is there, and the height, well, it's there. Turn sideways. I realize you can't do that on your paper.
Yeah, it seems a little fishy.
It's not fishy at all. It's as fresh smelling as freshly laundered towels. Remember, you're not going to have to do this. You just need to go through the experience. Okay. I'm coming up with, what I'm going to come up with at the end is a formula for displacement. And I'm going to show you how right away. I'm going to get to the heart of the matter here right away. Okay. So side 1 is this height here, right? Well, if this is velocity, then the height right here is really, it's the initial velocity. It's how fast it's going at the start. That's what side 1 is. And side 2 is this height right here, which is really the final velocity of the interval in question. So my area is side 1 plus side 2. So side 1 was my VI. Side 2 is my VF. All divided by 2. I'm taking this formula here, and I'm replacing it with the quantities on the graph. And I'm multiplying by the height. And the height was this distance here, which is the difference between the two times, which is my delta t. Okay, so what I've done, well, I guess my area is really the d. I'll go back to the start and I'll summarize. Okay? I'll go back to the start and I'll summarize. D, the displacement, is equal to the area, which is side 1 plus side 2 over 2 times the height. And side 1 plus side 2 is VI plus VF because of this, divided by 2. And the height is h, which is delta t, this distance here. Right here? That's the h that I turned sideways. It's the h that I turned sideways. Yeah. Well, because I rotate it, right? To show you that it was a trapezoid. Okay, now I'm going to take this form and I'm going to do some rearranging. Okay? So I'm going to write d equals, now, d, because the displacement is the area, right? I'm going to call it d now. Okay, how else could I write VI plus VF over 2? What's the other way to write that? Instead of divide by 2, I could multiply by a half, right? So I'm going to have 1/2 times VI plus VF. And again, I'm going to let the delta t just sort of become t, because 99% of the time, the initial velocity is, the initial time is 0. So I'm just going to, a lot of books leave the delta t in there. I think it's confusing for kids. Okay, now, here's something you're not going to like. I'm now going to replace VF with special equation number 1. I'm going to take the VF in that formula and replace it with VI plus AT. I'm going to put it right in there. I'm going to put it in a different color. And I'm going to write d equals 1/2 of VI. We're going to get there. It's just an experience you have to go through. VF is equal to VI plus AT. That was special equation number 1. Multiplied by t. 2 more steps. D equals 1/2 of VI plus VI plus AT bracket times t. This is why you got to do all that algebra down math lane. So you can sit back and enjoy this. We're going to get there, Wyatt. Okay, we're going to do some combining now. D equals 1/2 of VI plus VI is 2VI plus AT multiplied by t. Okay? And now I'm going to multiply it all together. And I'm trying to not go too fast here so that you can get it all down. So, it's going to be 1/2 times this times the t, right? So 1/2 times 2VI is 1VI, but that's also multiplied by t, so I get VIT. D equals VIT. This one times this one times this one. And then I got to take 1/2 and I got to multiply by AT, and then multiply by t again. So I'm going to have 1/2, exactly, Kieran, 1/2 AT squared. And that, my friends, is special kinematics formula number 2. D equals VIT plus 1/2 AT squared. It's going to become one of your best friends in the next couple of weeks. D equals VIT plus 1/2 AT squared. Pardon me? we want it in a nice compact form that generally solves for something that we're looking for. Quite often we're going to look for the displacement when an object has an initial velocity and is accelerating. This formula allows you to figure out how far something goes when something has an initial velocity and then accelerates over a given period of time.
Oh, so this is kind of like the proofs then.
Yeah, this is like a geometric proof, exactly. Or like when you guys do like the sine and cos and all that stuff in pre-calc, yes. Yep, same idea. We're coming up with a formula. Okay? I am not going to make you do all of that every time you want to solve a problem. All you got to do is write this. But to be able to write that, you have to have sat back and experienced all the glory that is this derivation. Okay? And you can say, I did it. You can add it to your bucket list. This, of course, is called special equation number 2. Okay. There's one more. Remember I said they get harder as we go. How do you feel about fractions?
I love that.
Yeah? Are fractions your friends? Or are you more like maybe half a friend, not so much? Yeah, a little joke there. Special equation number 3. You might want, if you're anywhere close to, like, if you're past past halfway, start a new side.
Really?
Yeah.
Oh, man.
If you're past halfway, you're going to need at least a half a page. At least. Depending on how big you write. If you've got a fresh, if you can turn it over and start fresh, I'd start there. I'm going to take equation 1 and I'm going to isolate t. Take equation 1 and I'm going to isolate t. Equation 1 was VF equals VI plus AT. We'll wait for Jared. We're going to take this one and we're going to isolate t. Can you do this in your head? Can you isolate t in your head? Take the VI to the other side, becomes VF minus VI, and then I'm going to have equals AT. How do you get rid of times by A? Divide. So I'm going to have VF minus VI all over A is equal to T. Okay, all I did was take this and isolate for T. Yeah, that's all I get. Yeah, no, there's more to it than that. And I'm going to place that into equation number 2. I'm going to take this value of t and I'm going to put it in d equals VIT plus 1/2 AT squared. I'm going to take this value of t here in red and I'm going to replace it for both of those t's. Now you understand what I'm saying about a whole new page. D equals VI, what's the red value of t? VF minus VI all over A. Okay, so I took this t here, and I took VF minus VI equal over A is equal to t, and I plugged this thing here into that t right there, right? And then I'm going to write plus 1/2 of A. And now the t again, VF minus VI all over A, and I'm going to square it. And I'll just pause there and let you look at that. You might not understand it, but do you see what I've substituted, right? Like I've taken this blue t and replaced it with this red part. I've taken this blue t and replaced it with that red part, and unfortunately this one's going to be squared. And obviously now I need to simplify, right? Okay, so I'm going to go in black because it's all combined now. Okay, so what does this become? VI times all of this is going to become VI times VF, VI, VF, right? I'm going to take this and I'm going to multiply. VI times minus VI is going to be minus vi squared all over a. That's the blue times the red, right?
Yeah.
Plus, now how are we going to do this? Should I do the squaring part first and then worry about the 1/2 times a later? Probably, right? Can I write 1/2 a another way? I like to write it as a over 2. So the 1/2 a becomes a over 2. Okay, now what happens when you square? Here's where you have to have learned binomial expansion in grade 10 pre-calc, I think. What's VF minus VI all squared? Mr. Ray or someone probably taught you x plus y squared.
Okay.
Yeah? You remember, Kieran? What is it?
Yeah,
X squared?
plus x y. Okay.
Just one xy? 2xy plus y squared. Do you remember that from grade 10? Looks kind of familiar? Okay. I really wish they would do that with VF and VI's. Because now the x squared is VF squared. Right? And the 2xy is going to be, now this is minus and that's plus. Does it matter? What if I made this a negative in here? Right? It's this instead of plus 2xy becomes. Do you remember that part? So this is going to be not x and y, it's going to be minus 2. Now, should I write VF VI or should I write VI VF? I've already got VI VF here, so I'm going to replace, instead of 2xy, it's going to be 2yx, okay? So this is going to be minus 2 VI VF. And then my plus y squared is this guy here. So minus VI times minus VI is plus VI squared. All over the, all over A? A squared. I told you this was going to be fun. I lied. It's mathematical fun, Ryan. I promise you that the final formula is much simpler than that, champ. Promise. I've never lied to you before, have I? Seems over excessive. I think your use of the word over, when you say over excessive, is over excessive. Hey? Okay. Okay. What do you feel should be the next step to do? Is there any simplification that we can do? We want to get rid of that half a. It seems to be causing trouble, doesn't it, right? So all I'm going to do here is I'm going to write that first part all over again, which I understand is a real pain in the butt, but it's got to be done. If you think it's a pain in the butt, think about how many times I've had to rewrite that.
Is the first one just over A?
It's just over a.
So it's not VIA.
No. What happens here? I got an a on the top, and I got an a squared on the bottom. Right? I'm multiplied by a on the top, and I've got an a squared on the bottom, so it ends up being just a on the bottom, but that's multiplied by 2. So the whole thing over here is all over 2a. When I take the a over 2 and I multiply that in by the a squared, I end up with a 2a on the bottom. Leaving the vf squared minus 2vi vf plus the vi squared all on the top. The top is unchanged. Now, I'll pause there for a second, because I know it's a bit. I'm about 3 steps away. How do you add fractions? Common denominator. People remember that. Sometimes they don't really know what that means. What does it mean, Helena? What is that, like, common denominator? What are the denominators here? Yeah, which in this case are a and 2a. So I need a common denominator. In other words, they both have to be the same. In this case, they both have to be 2a. I gotta make, it's like adding this. It's like going 1/2 plus 3/4. You gotta make them both quarters. Right? So how did I make the 1/2 into quarters? 2/4. And multiplied the top and the bottom by 2. So I gotta do the same thing here. So I'm gonna rewrite this whole thing over here, which I know is a pain. Rewrite that whole thing all over there. This is not part of it. That's just sort of me showing fractions. And over here, I'm going to multiply the top and the bottom by 2. So now I've got 2a, and it turned to blue for some reason. Didn't need to. I have to multiply the top by 2. I got to multiply everything by 2. So 2 VIVF minus 2 VI squareds. Getting really close. Now what do? When you add that 2/4 plus 3/4, well, the whole thing is all over the quarters, so it's all over 2a, and you add the tops together, and if there's any that happen to cancel out, then that's great. Okay, so, hey, look at 2 VIVF minus 2 VIVF. Party on. I got a minus 2 VI squared and a plus VI squared, which is going to result in a negative VI squared, right? Okay, what about the VF squared? It's got nothing to go with, right? Are you like me, or do you like the first term being positive? Okay, most people do. So I'm going to put the VF squared, the positive one out front, and then I'm going to have, well, look at that. That's pretty simple, isn't it? I made that big long line for nothing. Now, most books write this formula like this. I'm going to multiply both sides by 2a. This is the easy part. You can leave it like that if you want. Most books will put the 2a on the other side, so you're going to have 2ad equals VF squared minus VI squared. And again, most books like taking that minus 2VI squared to the other side, and you get like that. People tend to not like fractions in their formulas. Okay? And most places will write this as VF squared equals VI squared, right, so that we can read it. VF squared is equal to VI squared plus 2AD. And that, my friends, is special equation number 3. VF squared equals VI squared plus 2AD. You'll notice that what doesn't appear in the formula? The time. The time doesn't appear. How come? Because way up at the top, I took this value of t and I substituted it in there, and the t's disappeared. So we use this formula when the time is not given. When you don't have time, you got to use that one. VF squared equals VI squared plus 2AD. The jokes? Oh, okay. You can check that off your bucket list. You are now an exclusive club, because I would guess that probably less than 1% of the world's population has experienced the derivation of special kinematics equation number 3.
The second last equation has it down.
Oh yeah, there I am. Correct. Not many people can say that they've experienced the derivation of special equation number 3. No, it's not mine by any stretch. Not mine by any stretch. Now, I told you at the start that there's only 3. There is a 4th, but I'm not going to derive it because I do not want brains all over the floor because heads will explode if I do it.
I want to do it.
So I'm just going to give it to you.
No, please derive it.
No, 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 okay. No, no,
No,
no.
please derive it.
No, I'm not driving it. I never have and I never will. Mainly because I need notes to do it. That's how complicated it is. How many people remember the quadratic formula? Yeah? What is it, Karen? You remember? X equals? I need you to be a little bit more specific. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, did any mean, nasty ogre teacher derive that formula for you? No, I am not. Have you ever seen the formula derivation for the quadratic formula?
Yeah. Negative b plus or minus.
No, but the derivation, where it comes from.
Oh.
Yeah. Scary stuff.
Ugh.
Yeah. No, I am not.
Yeah.
I don't think I want anyone falling asleep. You do not want to see it. Yeah, I haven't seen it in years. Yeah.
We actually
Can I?
do.
You go right ahead. Yeah.
You guys don't.
Now, some of you may not know what this means. We are solving for when you've got something like ax squared plus bx plus c. Something like 3x squared minus 6x plus 4, right? And the a is 3, and the b is minus 6, and the c is plus 4. Okay? It will happen from time to time that you're going to need to use this. Okay? You will need to use it. You definitely do not need the form of the derivation.